What's up guys? This is Engineer Jack and this is Hydraulics. So ngayon, yung pag-usapan natin this time is the hydrostatic forces on a curved submerged surface. So the resultant hydrostatic force on a curved submerged surface is specified in terms of its components. So as you can see in the figure, this is the water surface or the liquid surface, and meron tayong submerged surface na yung nakikita nyo sa screen nyo is yung thickness of that surface. So ibig sabihin, meron siyang width perpendicular sa screen nyo. So meron tayong dalawang components na. So meron tayong vertical component and the horizontal component of our forces. So meron tayong FH and FB. So equivalent din yan sa, kasi itong curved surface, meron siyang projected area na vertical plate at doon natin makukuha yung hydrostatic force natin na FH. So, para siyang projected area, kung titingnan natin dito sa side niya of the curve, yung makikita natin is rectangular plate na parang vertical. And, syempre, kasama din yung vertical component, pero this time, yung kino-consider pag sinusolve yung vertical component FB is the liquid volume or yung dinadala of our surface. So yung pag-solve natin ng FH, yung first solution natin, pwede tayong magamit ng formula na gamma h bar times area. Or we can also use the integration. Actually, yung formula galing lang naman yan sa integration, the integral of pressure times differential area. So magkukonsider tayo ng strip and yun. And yung third solution natin para masolve yung FH, equivalent din sa volume of the pressure diagram. And para naman makuha yung FB or the vertical component of the hydrostatic force, equivalent lang yan sa the unit weight of the liquid times the volume, so yung volume na dinadala niya sa above the surface. So the horizontal force and its location are the same as for an imaginary vertical plane surface of the same projected area. So ito nga yung horizontal force na yung makikita natin is yung projected area na vertical plane surface. So rectangular siya. Yung thickness niya or yung width niya is perpendicular sa screen nyo. Tapos yung net vertical force naman will be equal to the weight of the fluid directly above the surface. So ito nga, so isosobrang natin itong volume na dinadala niya, itong area, times perpendicular width, perpendicular sa screen nyo na width, so multiply nyo lang yon, then yung makukuha natin is volume. Tapos multiply the unit weight of the liquid, then makukuha na natin yung vertical component or FB. So for example, ibahin natin yung orientation of our liquid. So ilagay natin sa kabila. Yung submerged natin is yung kabilang side naman. So itong liquid surface natin. Yung vertical component natin and horizontal component is baliktad compare sa kaninang example. So kanina nandito yung liquid and this time nandito yung liquid. So syempre babaliktad yung orientation nila. So yung FH to the left na and yung FB upward. Pero if we put liquid sa kabilang side, meron din tayong liquid dito. So this is in equilibrium, ibig sabihin, yung pressure dito, tsaka dito, equal lang. Wala siyang unbalanced force. Tapos, para mabalik natin dito, sa drawing na nauna, so magmaminus tayo ng liquid sa kabila, yung dinagdag natin. Ibig sabihin, kung ito, equilibrium, pwede natin masabi na itong drawing is equivalent to the opposite of this drawing. So, equal lang naman siya. So, dapat, pag magko-consider tayo, kung ganito yung surface natin, yung pag-solve natin ng vertical component, is same lang dapat dito, pag ganito yung orientation niya. Kung nandito yung liquid niya above. Kasi nandito, nasa below yung liquid natin, pero dapat equal lang yung behavior nila or yung kinukompute natin na volume. So, in summary, the magnitude and location of the vertical fluid force FB are given by the weight and location of the centroid of the fluid above the gate. Kahit nasa below yung fluid natin na nag-act sa curved surface natin, always i-consider natin yung volume above. So kahit walang liquid talaga dito, yung i-consider natin na volume is always yung above. And the magnitude and location of the horizontal fluid force, FH, are given by the magnitude and location of the force on an equivalent vertical flat plate. Kanina nga, sabi ko nga, meron tayong projected area pag i-consider natin yung horizontal fluid force. So, for example problem, this example problem, so meron tayong curved surface na may given equation, and this is the surface of the liquid. So, basahin ko muna yung problem. The gate shown is hinged at O, so ito yung O, and has constant width. So, yung width natin merong 5 meters, and itong width, this is perpendicular sa screen nyo. So, the equation of the surface is x is equal to y squared over a, where A is equal to 4 meters. The depth of water to the right of the gate is D is equal to 4 meters. Find the magnitude of the force FA applied as shown, required to maintain the gate in equilibrium if the weight of the gate is neglected. And dito nakalagay yung FA natin o ito yung hahanapin. So dapat masolve natin yung FA na dapat yung gate natin dapat in equilibrium siya. So as you can see, yung liquid natin nasa below of the gate. Ibig sabihin, yung vertical component niya is going upward and yung yung horizontal component is going to the left. So just like kanina na unang slides, ganun pa din. So una, pupunuin natin yung gate natin. So maglalagay tayo ng fluid dito. So it is in equilibrium. Ibig sabihin, itong drawing, equivalent din dito, opposite lang kasi negative. So yung FB natin dito is upward and dito downward. So yung i-consider natin na volume para makuha yung vertical component is yung upward na area or the volume of the water dyan. So ito pa din yung kukunin natin na volume. So first, kunin muna natin guys yung horizontal component or the horizontal hydrostatic force. So meron siyang projected area na rectangular nga na merong height na 4 meters and the width na 5 meters. So para masolve natin yan, we have 3 ways. So una, we can use the formula na unit weight h bar times area. So substitute. So meron tayong unit weight na this water. So 9.81 kilonewton per cubic meter times yung h bar natin that is from the centroid or the center of gravity of the plate from the water surface. So that is 2 meters kasi kalahati ng 4, that is 2. Times area, na yung area niya is 4 meters times 5 meters. So i-calculate natin. So that is 392.4 kilonewtons. Another solution, we can also use the integration or the integral calculus. So una, kuha muna ako ng strip and yung thickness niya is differential y. Tapos yung location niya from the water surface or from the top of the plate, that let's say that is variable y. So yung formula natin para makuha natin yung hydrostatic force or horizontal hydrostatic force, that is equal to the integral of pressure times differential area. And yung limit natin is kung ano yung dadaanan of our strip. So from yung dadaanan niya is from 0 to 4 lang. That is also equal to yung pressure natin is also equal to the unit weight of the fluid times yung y kasi yung h bar natin is yung from the centroid of the strip from the water surface. So yung variable natin is y times yung differential area or yung area ng strip which is differential y times yung length niya is 5. So 5 meters times dy, that is the differential area. So integrate. So meron tayong 5 times unit weight of the fluid. Yung y natin by our formula, that is y squared over 2 from 0 to 4. So substitute. So 5 times yung unit weight of the fluid, 9.81 kilonewton per cubic meter times 4 squared over 2 na dapat same lang nilalabas na 392.4 kilonewton. So pwede nyo guys i-pause yung video and i-calculate kung tama ba yung 392.4 kilonewtons. And another solution natin para makuha yung horizontal component, we can also use the volume of the pressure diagram. So para makuha natin yan, so i-draw muna natin guys yung pressure diagram, tapos kunin natin yung pinakailalim na pressure. So yung pinakailalim na pressure niya is gamma H. So yung H, this is 4 meters. So kung gagawin natin na 3D, ito yung drawing niya or ito yung pressure diagram na naka 3D. So yung volume niyan is equivalent to yung constant na area which is the triangle times the width W. So, yung area of the triangle yan, kaya 80, ibig sabihin, that is 1/2 unit weight times H, base pa lang to, times height, ito na yung area of the triangle, times W, ito na yung volume, or equivalent hydrostatic horizontal force. So, substitute. So, meron tayong 1/2 times 9.81 times 4 ulit, times 5 meters na width. So, makuha pa din natin is 392.4 kilonewtons. And dapat same lahat sila, kahit anong solution, sa solution 1, calculus, and even sa pressure diagram, dapat same lang. So, ginagawa lang natin yan para ma-check na tama yung solution natin. Ito nang gagamitin natin na horizontal component of the hydrostatic force na 392.4 kilonewtons. So ngayon, isolve naman natin yung vertical component of the hydrostatic force na formula niya is unit weight of the fluid times volume. Pero sabi ko nga kanina, dapat always above yung i-consider natin na volume. So parang ipoproject na natin yung projected volume above. So yung projected volume, ito yun. And para makuha natin yan, gagamit tayo ng integral calculus. So yung volume niyan is equal equal to area times width. So, dapat isolve muna natin itong area using calculus times yung width na perpendicular sa screen nyo na 5 meters na given. So, first, kuha muna ako ng strip. Kung vertical yung kinuha ng strip, ibig sabihin yung thickness niya is differential x. And dyan natin makukuha yung differential force natin or yung FB. Yung location niya from y-axis, let's say that is x, and yung location niya from x-axis o itong at this point, so that is y naman na variable. Kasi hindi pwede natin sabihin na itong dulo niya, that is not y, kasi itong total height, that is 4 meters. So, given na. So, yung variable natin, syempre, hanggang dun lang sa curvature natin. Hanggang dyan lang yan. Ibig sabihin, yung length of the strip natin, that is 4, yung total height, minus y. So, ito yung length of the strip, so 4 minus y. So, to solve the area, equivalent lang yan sa differential area or the area of the strip na yung length nga is 4 minus y times yung thickness niya, differential x. Yung limit niya is yung dadaanan niya from 0 to x kasi hindi natin alam yung value or the abscissa of this coordinate. So, dapat makuha muna natin yan. So, gagamitin natin yung equation of the surface or the curvature. So, meron tayong given na equation na x equals to y squared over a. Na yung a natin, that is 4 kasi given yan. Ano ba yung value of x natin at y equals to 4? Kasi yung ordinate niya is 4 meters. Yung hinahanap natin is yung abscissa. Just substitute the value of y na given nga, yung ordinate niya is 4 meters from x-axis. So, that is 4 squared over 4. So, meron tayong 4 squared over 4, that is 4 meters, and this is the value of x. Ibig sabihin, yung limit natin is from 0 to 4. But before natin makalculate yan, using our calculators, kasi pwede natin yan i-calculator agad, dapat consistent tayo sa variables. Kasi yung hindi natin ito ma-integrate, kasi yung y natin, dapat in terms of x. Kasi naka-differential x tayo. So, meron tayong x equals to y squared over 4. So, cross multiply. So, this is 4x, then square root. Ibig sabihin, yung y natin is equal to the square root of 4x. Or pwede pa natin ma-simplify, that is 2 square root of x. Saka natin is-substitute dito sa equation, then saka natin i-calculator. So, that is 4 minus 2 square root of x times differential x, and yung limit niya from 0 to 4, kasi ito nga yung dadaanan of our strip. And that is also equal to 16 over 3 square meters. So, pwede nyo guys i-pause yung video and i-check kung tama ba yung pagkakalculate ko. Dapat 16 over 3 yan. So, this is now the area. So, para makuha natin yung vertical component, that's the unit weight times volume, and yung volume, that's the area times yung width. So, substitute the values. So, meron tayong 9.81 kN per cubic meter times yung air na 16 over 3 times yung width na perpendicular sa screen nyo, which is 5 meters. So, meron tayong value now na 261.6 kN for the vertical component of the hydrostatic force. So, pwede nyo guys ulit i-pause yung video and i-check kung tama ba yung pag-calculate ko. So yun, nakuha natin guys yung horizontal component and the vertical component. Hindi pa ito yung final answer kasi yung hinahanap natin is yung force FA or itong variable na to. So para makuha natin yan, kailangan natin mag-moment at the hinge kasi yung moment at the hinge is always 0. So inaral natin yan sa structural theory or even sa mechanics natin. So pwede tayo guys mag-moment about point O. So let's say summation of moment about point O equal to 0 or equate lang natin lahat ng clockwise moments sa lahat ng counterclockwise moments. So yung mag-create ng clockwise moment is yung FA times yung perpendicular moment arm niya from point O, that is 5 meters equal to, and yung mag-create naman ng counterclockwise moment is yung vertical component kasi yung vertical component niya is going upward, tapos yung horizontal component naman na going to the left. So mag-create sila ng dalawa ng counterclockwise moments. Yung moment arm of the vertical component is yung variable x. So kung ayaw natin guys yung mag-calculus, itong solution kasi gagamit tayo ng calculus. So kung hindi tayo gagamit ng calculus, dapat ilocate natin yung centroid of this area, tapos doon nakalocate yung vertical component FB. And instead na kumuha tayo ng centroid, diretso na tayo sa calculus. So ilalagay natin to sa equation sa calculus na FB times x. So isang equation na lang siya. So hindi na tayo gagamit ng mga formulas to solve the centroid. And kahit din naman sa horizontal component of the hydrostatic force, yung gagamitin ko na perpendicular moment arm is yung 4 minus y. Kasi yung y natin is from the surface of the fluid or water. And syempre, yung gagamitin natin moment arm is from O. So, ibig sabihin, that is 4 minus Y. So, yun. So, yung FB nga natin, that is the unit weight times volume. Yung volume natin, that is the area, times yung width perpendicular sa screen natin. So, kung nag-multiply tayo ng X, i-multiply din natin ito sa kabila, then, saka tayo mag-integrate. So, integration natin this time for FB times X, or this is the moment from point O, the unit weight times W, ito yung width of the surface na 5 meters, times the integral of, yung kaninang equation natin is 4 minus 2 is square root of x lang times dx. Pero this time, mag-multiply pa tayo ng x para maging moment. So, substitute the values, meron tayong unit weight na 9.81 times yung width na 5 meters kasi that is constant. And itong value, pag in-integrate natin sa calculator, that is also equal to 6.4. Ibalikan ko lang and i-pause nyo yung video and i-check kung tama ba na dapat that is 6.4. So, dapat 6.4 yan. And 9.81 times 5 times 6.4, that is 313.92 kilonewton meter. Take note, dapat yung FB times X, dapat naka-kilonewton meter kasi yung unit of X is meters. So, let's say, ilagay ko lang dito yung value of FB times X. Ito na yung value. Ngayon, kukunin naman natin yung value of FH times 4 minus Y. So, yung formula natin kanina for FH using calculus, the integral of PdA, or that is also equal to the unit weight times Y times differential area, which is 5 times dy, or the area of the strip. If we multiply moment arm na 4 minus y, mag-multiply din tayo sa kabila, kaya magkakaroon tayo ng equation na mahaba, which is the unit weight times y times 4 minus y times 5 times dy. I-pause nyo ulit guys yung video and i-check sa calculator kung ano yung value niyan. So, dapat yung value niya is 523.2 kilonewton meter. So, balikan ko lang para ma-check nyo ulit. Yun. So, that is 523.2 kilonewton meter. So, sum natin. So, ibig sabihin, FA times 5 meters, that is 313.92 plus 523.2 na yung unit nila is kilonewton meter. So, yung sum nila is 837.12 kilonewton meter. So, divide both sides by 5 meters. So, dapat makukuha natin is kilonewton for FA. So, the value of FA now is 167.424 kilonewtons. And ito yung sagot or answer for this example problem. So in summary lang, kung mag-solve tayo guys ng curved surface, so dapat pag nandito yung liquid sa ilalim, always i-consider natin yung projected volume above. Ganun pa din yung dapat yung i-consider natin na volume. And that's it. Thank you very much. So this is the last part of in solving the hydrostatic forces on our submerged surfaces. Thank you for watching and have a good day.